Okay, let's have a look. And you know the scene. I'm going to ask Ayanda to walk around, and we're going to try and do some of this stuff quite quickly and easy. I think that the data handling is quite straightforward. Let's quickly get an answer for the median for class 1. Just put your hand up. Ayanda will come to you. She will bring the microphone. I don't think guys, this is a nice, easy question first up. There we go. We have an answer. $60, well done. Okay, can you quickly remind me while you've got the microphone, especially if Ayanda's going to give you sweetie in Nani. All right, what does this number here represent where the tail starts? The minimum. Okay, well done. And this one here? Q1, hala, and this one here is Q2 or the median. This one? Q3, and this one the maximum. Okay. So that's really, really important. Okay, someone else. The interquartile range for class 2. Okay. Now, guys, I want to talk to you quite a lot today. I'm going to talk to you about exam technique. Okay, exam technique. So I'm going to show you something here. Tell me how you're going to do this.
Interquartile range is equal to Q3 minus Q1.
Yeah.
80 minus 53.
80 minus 53 equals
27.
Okay, now guys, listen carefully to what I'm going to say now. If in the exam you just write 27, okay, I'm looking at Ma'am Ngele because she goes to the marking, okay. I think on a question like this, they will probably give you 2 marks. I hope so, okay. Cordway. If you misread one of these numbers and you just write 29, how many marks? Lutu. Okay, nothing. Right. This is so important because even if you go 80 minus 53 and you say, oh, that's 26, you will still get this mark here. Okay, so try always to show your working. All right. Remember that if you take 1 mark, if you take 1 minute per mark, that bird, hey, I don't know what it's saying. Okay, guys, 1 minute per mark. If you do that, you will have half an hour left at the end of the paper. Okay, to check. All right. So you guys get time at the beginning of the paper. I think I'm right in saying for reading. Do you? Yes. Yeah. You can use that time in one of 2 ways. I like to look at the paper and just look through and see what it looks like. All right. Some people like just to relax. Okay, just to breathe deeply, not to be anxious, maybe pray quietly. Okay, you've got time. But maybe you can do both things. Okay, you can have a look through the paper, and then once you've looked through the paper, just put it down, close it, close your eyes, just think and think. Okay, all right. Now, we now asked to talk about the skewness or the symmetry. Okay, let's get an answer, please, for class number 1. It actually says in both classes. Okay, all right. So we've got to do both. Anybody want to tell me what's the answer for are these is this data skewed or is it symmetrical? If it's skewed, which way is it skewed? Put your hand up if you've got an answer. Okay, we seem to have far fewer people with answers here. That's a bit worrying. No one sure. Okay, we've got an answer here. Have you got an answer? How much? Negatively skewed. All right. It's actually not negatively skewed. Okay. All right. Guys, it is positively skewed. It is skewed to the right. Okay. Now you can, both of them, both data sets are skewed right. Okay. They are positively skewed. What that means, okay, because often people will say, sorry guys, the word, we can either use right or we can say positively skewed. Okay. You can say either thing. Now, a lot of people, when you ask them why, they say this. They say there's more data above the median than below. Ai Koliento. The median is in the middle, guys. There's not more data above than below. All right. But what is true is that the data above the median, here's the median for both, the data above is more spread out than the data below. Okay, so that's the reason. Okay, I've done that for the top one, but even for the bottom one. In both cases, the data above is more spread than the data below. And they've asked us to say why. So don't say there's more data above. There's not more data above. The data above, the data bigger than the median, is more spread than the data below the median, than the data less than the median. Okay. Then it says give P if 75% of the candidates achieved a mark greater than P in class 1, in this class here. 75% achieved a mark greater than some number. Who can tell me where are we going to read off 75%? And this tests your understanding of quartiles. Where? Anyone? Yeah.
We're going to read 75% from Q3.
Okay, it says 75% achieved a mark greater than. So not from Q3. Q3 would give us 75% less than. Guys, this is 25% of your data. This is 25% of your data. This is 25% of your data. And this is 25% of your data. Okay, so if you look at Q3, the only place 75% is going to come in with Q3 is less than. Okay, which one must we actually look at? We must look at? No. So we want a mark that's 3/4, 75% achieved a mark greater than. So 3/4 achieved a mark greater than what? Which number is going to tell us that? Guys, I'll tell you just to show you, this here would be 50%. 50% achieved a mark greater than 60. So if I want 75% achieving a mark greater than, where must I look? I'll give you a hint. It's one of the quartiles, but it's not quartile 3. Q1, guys?
Q1.
Yeah, Q1. Okay, there we go. There it is. So Q1, I think, is 54. I'm not sure if it's 54. Maybe it's 55. 1, 2, 3, 4. 54. Do you see that 25, 50, 75% of people got a mark bigger than 54? So P is 54. Okay, on my memo here, I'm saying 53, so I'm not sure if I'm reading it correctly here, but let me just check. That's 51 to, it's actually 54. Okay. Which class has the greatest standard deviation? Who can tell me that? And this really tests your understanding of what are we talking about with standard deviation. Anyone? Just put your hand up. Okay, guys, standard deviation, I'll give you a hint. Standard deviation is a measure of spread. It's a measure of how spread out the data is. Which data is more spread out? Class 1 or class 2? Class 2. So class 2 has the bigger standard deviation. Okay, and the reason class 2 has the biggest standard deviation, the data is more spread. Guys, you know, I'm hoping you know how you calculate standard deviation. We're probably going to have a question on that now, so let's move on. Okay, all right. Let me just see if we haven't got a question on that. Okay, we're now looking at let's just quickly talk about that before we move on. Okay, you get given this formula here. All right, sigma squared equals I equals 1 to n xi minus x bar squared over n. All right, this gives us the formula for sigma squared. Sigma squared is actually called the variance. All right, and to get our answer, we would square root it. Okay, now if I look at, I'm just going to give you 3 numbers. Okay, I'm going to give you 3 red numbers and 3 green numbers, and we're just going to quickly do this. So the 3 red numbers are 4, 5, and 6. All right, the 3 green numbers, okay, I'm going to do over here, they are 1, 5, and 10, and 9. Okay, which ones are more spread out? The red or the green? The green. The green are more spread out. Okay, for both of them, if we add them up, all right, and divide by 3, for both of them we get the same mean. This one, the average, 4, 5, 6. If you add them up, you get 15. Divide by 3, you get 5. This one over here, 1 and 5 and 9, you add them up, you get 15. You divide by 3, you get 5. Okay, now I want you to look at what the formula says. The formula says you take each number, you minus the mean, you square the result, and you add them together, and then you divide by how many there are. So I'm going to just very quickly here, I'm going to do that calculation. If I go 4 minus 5, I get -1 squared. If I go 5 minus 5, I get 0 squared. And if I go 6 minus 5, I get 1 squared. Okay, I add all of those up and I divide by 3. Okay, and so I get 1, 2, 2 over 3, and my standard deviation, remember I've got a square root to get the standard deviation, will be the square root of 2 over 3. Okay, let's do the same with the green ones. 1 minus 5, -4. 5 minus 5, still 0. 9 minus 5, 4. And I've got to divide by 3. So here my sigma will be 16 and 16, 32, square root 32 over 3. Okay, I'm going to show you how we can do these calculations on the calculator. All right, because it's important that you know how to do that. Okay, so I'm just going to bring up my calculator. All right, there it is. Okay, so remember what we're going to do? We're going to go mode 3. It's not 3. We're going to go mode 2. All right, 1 variable, and we're going to put in the numbers 4, 5, and 6. Then we go shift stat 4 for the variables about this data, and then 3 for the standard deviation. And what we get is 0.816. All right, now what I'm going to show you, all right, is that if you square 0.816, because that's the standard deviation, if we square it, we will get 2 over 3. All right. 2 over 3, 0.6666. Okay, so this one is actually, this one's 0.816. And this one is the square root of 32 over 3. Okay, I'm not going to, this time I'm just going to I'm going to go back to the answer that I've got, the square root of 32 over 3. Guys, this one is 3,3,3. Do you see that the green one has a bigger standard deviation? It's more spread out. Okay. All right. Now, the next type of data handling, and this is very often asked, grade 12 topic, it's around what we call bivariate data. So we've got two different data sets here. Okay. There's two things when we talk about a relationship, when we talk about correlation. Okay. There's the direction and the strength. Okay. Who can tell me this data, is it correlated? Is there a relationship? Yes. Okay, so let's get someone on the mic. Tell us, is it a positive correlation or a negative correlation? Is it strong or is it weak? Okay, I want someone on the microphone, ideally. Okay? Strong or weak?
I think this is a positive, strong.
Well done. Well done. It's both those things. Guys, it's positive. It's positive because as the one quantity grows, so does the other quantity grow. All right. The correlation coefficient here would be it would definitely be positive. All right. And this is quite strong. Okay, I'm guessing here maybe that we might get something like 0.8. All right, for our correlation coefficient. Okay, I'm going to quickly see if I can find something here in my search all my bookmarks. Okay, here we go. All right. So guys, let's have a look here. Okay. Anybody, is that a weak correlation, strong correlation? Guys, I think it's weak. I don't think there's much pattern here. I'm actually going to say 0, okay, and I'm going to say show the correlation. Okay. It was negative 0.38, okay? Let's try another one. Is this positive and strong? Is this negative and weak? It's positive and quite strong. Okay, I'm going to go for 0.7, all right? 0.7. Okay, and I'm going to say show the correlation, 0.83. Okay, so I wasn't too bad there. Is this negative? This is negative. I think it's not as strong. I would say maybe negative 0.4, or 5 maybe. I don't know. Okay, negative 0.45. Okay, all right. Are you guys comfortable with how you work out the correlation coefficient and the equation of the line of best fit? Do you know how to do that? If you get a table on your calculator, so let's say it's height and weight, right? And we've got some people here, and this one is, say, 180 and 73, and this one, say, 160 and 70, and this one, say, 185 and 78, and this one, say, 145 and maybe 69. Okay, maybe it's like that. Okay, you guys know how to do this. I'm not going to do the whole thing. I'll just quickly show you. You go mode, you go to, and you go to variable stats. All right, and then you put in the numbers. When you press equals on your calculator, it goes down. So it's easier to put in all the first column first, 185, 145. Okay, and then go back up, but we must make sure that we get this data right. 73, 70, 78, and 69. There's no opportunity to show any working here. So it's very, very important that you put the data into your calculator. Now you go shift stat, and you're going to go for 5, which is regression. And you're going to get 3 things. You're going to get A, B, and X. So A is 39.8. B is 0.195. So our line of best fit is 39,8 plus 0,195 times x. Okay, and if we get our correlation coefficient, we go shift stat 5, 3, and we get 0.89. What does 0.89 tell us? Is it strong? Is it weak? Is it positive? Is it negative? Strong, positive. Okay. All right, are we okay with this? Then it says, the teacher plans to use the equation, all right, to predict a score for a learner who only got 30% for maths. So we've got an equation here for this straight line. Now, the teacher is saying, let's see where that straight line is at 30. Is this a good idea or a bad idea? Is there any risk in doing that? Can anyone tell me about this? Okay? Anyone, put your hand up if you... Guys, I want you to look where the original data was. These are the original data points, okay? And all of them were between here and here. All right. Now, the teacher is going to use this mark, use this tool, this line, okay, to approximate for 30. Anybody know? All right? It's probably quite important that we tell you. Okay.
I don't think it's safe to use that word because the data was extrapolated.
Well done. 100%. Halala. Okay, guys, what we've got here, we've got something called extrapolation, okay? And I have huge sympathy for you guys in terms of the language, okay? But extra, the word extra in English actually means outside. Okay? And I'll tell you where we come across that word in everyday life. When we talk about a word like extraordinary, okay, it actually means outside of the ordinary, okay, unusual, extraordinary, okay. In schools, we'll also talk about extracurricular, outside of the curriculum, okay, all right. But guys, what we're doing here is we're going outside, okay. I think you guys know, am I right, that when people get, if you had to plot, let's just talk about people. If you talk about the age of people and the height of people, do you agree that when people are young, they're quite short, and then as they get older, they get taller? Yes. But does that pattern continue forever for your whole life? No. If it did, we would have people who are like 6 meters tall. Okay. In Rulamiti. Okay, we don't get that. All right. So what actually happens with height is it actually stays the same after a while. Like, I'm not getting taller now. And in fact, often with old people, okay, they actually start to get a bit shorter as they get older. Okay, so that would be a case of extrapolation. All right, if you only had some data for people who were up to, say, 25 years old, and you had a line of best fit, it would be a problem in Kiinga if we used that line outside. Does it make sense? Okay. All right. Where's there an outlier here? Anybody see an outlier? Okay, it's this. It's hard for you to tell me which one it is, but guys, it's this point over here. That's an outlier. It doesn't really fit very well with the rest of the data. Okay, so now it says what would happen? What would happen to the correlation coefficient if we removed that outlier? All right, and also what would happen to the gradient of the line if we removed that outlier? Now I'm going to load a sketch here. All right, which I hope I'm going to be able to find easily. Okay. All right. Have a look at this sketch when it eventually loads. Okay, this red dot, I'm calling this dot an outlier. Okay, so if I show the line of best fit, there's the line of best fit. And if I show the correlation, it's 0.45. You're probably thinking, Paul, why is that correlation so low? Okay, it's so low because of that red point. Watch what happens if I show the correlation without the red point. It's 0.95. Okay, all right. I also want to show you, if I put this red point, if I put this red point like right up there, you see the line of best fit. What do you think will happen to the gradient if I draw the line of best fit without that point? Will the line drop down or will it get steeper? It will drop down. Have a look. Okay, guys, the blue line is the line of best fit only for the blue points. The red line is the line of best fit for all the points. Okay, all right. And obviously, if you remove an outlier, your correlation will always strengthen. It will improve. Okay, so let's look at the answer now. What will happen to the correlation coefficient? Will it grow bigger or smaller? Well done. It will grow bigger. It will grow, all right? Or we could also say it will get closer to 1. All right. And what will happen to the gradient? Will the gradient increase or decrease if we take that point out? Guys, it will increase. It will increase. That point is almost pulling the line down a little bit. Okay, I'll show it to you on here again. Okay, if our outlier is right down here, okay, you can see, all right, so there's the outlier. All right, the outlier is low, like in our picture. All right, there's the line of best fit of all the points. The line that I'm going to show now is the line of best fit only of the blue points. If I leave out the outlier, the gradient actually increases. Does it make sense? It always makes sense. Okay, all right, it will increase. Okay, now guys, now we are moving on to some analytical geometry. And a quick reminder of the skills. We've got distance between 2 points. We've got gradient. We've got midpoint. We've got equation of a line. And we've got equation of a circle. And then we've got a big idea of angle of inclination. Okay, I want us to start off by talking about this. Okay, and I'm going to find a sketch and I want you all to take your calculators out. All right, I want to find this sketch over here. All right, so I want all of you to work out for me what is the angle of inclination of this line right now. Okay, I want you to work it out. Okay, so the first thing I'm going to ask you to do is I'm going to ask you to work out the gradient. All right, I prefer to use rise over run. Is this line going uphill or downhill? Yeah, guys, we always go from left to right. Don't say, oh, Paul, if we're coming that way, it's going downhill. In South Africa, we read from left to right. We don't read from right to left. We're not in Korea or China or somewhere where they go the other way. Okay, all right. Is this line got a positive gradient or a negative gradient? Positive. How much is it rising from there to there? Guys, from -3 up to 1, and not 2. You can even count the squares. 1, 2, 3, 4. Guys, if you're at -3 and you go up to 1, you've gone up by 4. All right. How much is it running across from 5 to 9? Also 4. What is its gradient? 1. Okay. Its gradient is 1. It's rising 1. It's running across 1. Okay. I think you could even tell me by looking here, what will the angle of inclination be? 45 degrees. How would we do that on a calculator? We would go shift tan of 1. Okay, now what I want to show you is where the angle of inclination is. Okay, guys, the angle of, I'm going to show a horizontal line, and I'm going to show the angle of inclination. Do you see that it doesn't matter where my horizontal line is? Because these are all corresponding angles. When I move the line down, I get a corresponding angle. Okay. So it's always 45 degrees. Okay, are we okay with this? Now, if you show the gradient is 1, and if you show the calculation, then, okay, I don't know where my calculation's gone. All right, my calculation's not on the screen. I don't know why. Okay, it doesn't matter. Okay, right. Now, guys, I'm going to ask you to do another one. I'm going to move these points around, okay? I'm going to see if I can. I'm going to delete all of that. Okay, all right. I'm going to change these points, and I'm going to put this one over here, and I'm going to put this one over here. And I want someone to tell me, I want someone to write down, you can just write somewhere, even on the back of the page or something, tell me what the gradient is and what's the angle of inclination now for this line.
The gradient is 2/5.
Well done. Halala. The gradient is 2/5. What's your angle of inclination?
21,8 degrees.
Okay. Let's have a look. 21,8 degrees. Halala. All right. Okay. Guys, let's do another one. Okay. Because now it's going to get slightly more interesting. Okay. Because now we've got a negative gradient. All right. We've got a negative gradient. And remember that our angle of inclination is going to be like in here. If my horizontal line's here, this is going to be my angle of inclination. Who can tell me what's going to happen now? What's the gradient? Someone tell me, what's the gradient first? Is it a positive gradient or a negative gradient? Negative gradient, yeah, okay. Carry on.
It's a -3/2.
Well done. That's the gradient, okay? Now, we know that the tan of this angle is -3/2. Okay, now I'm interested to know what you did next to tell me the angle of inclination. What did you do?
Arctan -3/2.
Okay, so this guy did arctan -3/2, okay, and what did you get?
-56,
Okay, we won't get too accurate. Let's just go -56.3 degrees, okay?
+180.
So, all right, now, okay, that is definitely not a negative angle. This, what you've said now is you've added 180, and what did you get? You get 1, 2, 3, 7 degrees. Okay, let's just check it. Okay, there it is, 1, 2, 3, 69 degrees. There's the horizontal line, and we can move the horizontal line down. Okay, 1, 2, 3, 69. Well done. Okay, all right. Okay, guys, I actually do it slightly differently. All right, I don't put this negative into the calculator. So in other words, I would say just arctan of 3/2. All right, and then I would get 56,3, and then I would say to myself, I want an angle in the second quadrant for tan to be negative, and I would go 180 minus 56,3, and I would get exactly the same answer. Okay, right. What I want you to do now, I've been doing lots of talking and lots of working, okay? I want you to do just the questions. Sorry, guys, I see the pages of the numberings, the questions have slipped here. I'm sorry about that, okay? All right, I want you just to try this question, the rest of this question. So it's 17 marks. I'm going to see if you could do at least some of it in the first, like even in 5 or 7 minutes, okay? So I'm going to give you a bit of time to try. You're welcome to talk to the people next to you. If you're not sure how to do one of the questions, just ask someone next to you. But let's make start on this question. Okay. All right. I under you. Are you taking some photos today? Yeah, please try to get some nice clear photos, okay? Because we need some for our school magazine. Okay, so yeah. I under also, if you can, or if the teachers, maybe even the teachers can just come. If the teachers can come, there are 2 memos here. Please take one of each. Okay, so the memo for this workbook, but also the memo for the DBE paper. And for the schools that are joining online, I'm going to put those 2 memos on the WhatsApp group now. I'll also put the soft copies of the workbooks. Okay, so I've put on the online group, I've put the memos and the workbooks. All right, I'm going to ask someone. I know I said that I was going to give you time to work on it. I'm going to ask someone just to quickly, just to make sure we all have got off to a good start, someone to tell me, how can I show that ABC is 90 degrees and what did you do here? All right, here we got it, under right at right at the bottom front here with, okay, no, we're not going to you, we're going somewhere else. All right. Okay, and please let their hands up, guys. There were not many hands up just now for some of the other stuff. Remember, singa keta, singa haman, jego kalukuni, normal singa D's and jego kozi. Okay, we want to be soaring like an eagle, not walking with turkeys. Right, let's have a look.
We're going to find the distance of AB.
Okay.
4 square root of 5.
Okay, so this distance here, all right, is you telling me that it's 4 root 5 as a distance? Is that your final answer? It's yeah. Okay, I'm happy with that. I think I'm happy with that. It's 64. It's 8 square 64 and 16. It's 8. Yeah, it's 4 square root 5. Yeah, and this distance. What did you do next?
2 square root of 5.
Okay. And then?
Yeah, AC
10. Okay. And then what?
We use the cosine rule.
Sure. Okay. All right. That's interesting. Use the cosine rule. Okay. And you got this angle is equal to 90 degrees. Yes. Okay. Guys, I can think of 3 ways of doing this question. All right. That's one way, is to work out the lengths and to use the cosine rule. How else could we use the lengths if we use the lengths? Sorry, I'm just coming to you. How else could we use the lengths? So having got this, this, and this, what could we do?
We can calculate the gradient of A.
Okay, sorry, yes. Okay, so that's a different method. And keep the microphone. Guys, the other way we could use the lengths. Do you agree that if these lengths square and add to, 2 of them square and add to the other one squared, it must be a right angle? We are using the converse of Pythagoras. So having got the lengths, we could use the cosine rule. Okay? We could use the converse of Pythagoras? All right. To be honest, I wouldn't have done that this way at all. The answer I'm going to get now, I think, is the way I would have done it. But it's all good. Okay. Yeah. What did you do?
Okay, I calculated the gradient of AB.
Yeah. What did you get?
It was -1/2.
Well done.
I also calculated the gradient of BC, which is 2.
Okay. Then what did you do?
And then if I multiplied the 2,
Yeah.
I got -1. And then I considered that AB is 90 degrees.
Well done. Okay. Very nice. So guys, there are 3 different ways of doing it. Not one of those methods is wrong. Okay. But I think maybe the most obvious one is that one. Okay. So we now know that this is a 90-degree triangle. Okay. Now, very often in maths, okay, it says hence. Hence means using what we've just done. Using the above. But it does say, or otherwise. Okay. All right. So, who can tell me now, to find the area of this triangle, what are we going to do?
We are going to use the same rule.
The sun rule. Tell me what you're going to do.
It's 1/2
Yeah.
into 4√5
Yeah.
multiplied by 2√5
Yes.
times sin 90.
Okay. Well done. Times sin 90. Guys, what is sin 90? It's just 1. Do you agree that this is also half base, if this is the base, times height, if this is the height? So do you see how we don't need to use an area rule, the trig area rule, but we can. Okay. What did you get for your final answer?
20.
20 what? Well done. It must be 20 units squared. Guys, you'll notice I'm not writing the answers always where you've got space. I'm hoping that you guys, on this thing, that you can see these questions here, you can still see the sketch. Am I right? Yes. Okay. Now, who can tell me how we can find another point over here somewhere so that we've got a rectangle? Okay, and this is quite an important idea. And the same thing works for a rectangle or a parallelogram. How can we do that?
We know that A, C are diagonal facets. So the midpoint of A, C is equal to the midpoint of B in that point.
Yes, well done. That's a clever way of doing it. Okay, so what we're saying is that the midpoints of these diagonals will be in the same place. All right. So what's the midpoint of this diagonal?
It's -1:0.
Well done. -1, 0. Okay. Now, if that's the midpoint of this diagonal, okay, then we could do a little equation with x and y, all right? Or we could say, how far have I moved from 4 to -1? How much is it decreased? It's decreased by 5. And if I decrease by another 5, where will I be? Well done. -6 is to 0. Okay. So guys, I haven't drawn this well at all because obviously this point's over here and this point's on the axis as well. All right. Can I show you another way of doing it? That's an excellent way of doing it. All right. If we go down this side of the rectangle, the exact same things must happen to x and y as if we go down that side. Are we okay? All right. So let's look at what happens to the x value when I go from point B to point C. What does it get, bigger or smaller, and by how much? It gets smaller by 2. So if we do the same thing here, this x value must get smaller by 2 to -6. What happens to the y value when I go from here to here? It gets smaller by 4, and so this one must get smaller by 4, and I get that point. Okay. If you wanted to check yourself, you could do exactly the same with these two sides. All right? When we go from B to A, the same thing must happen as when we go from C to B. I'm not going to do both, but how much has the X changed when I go from B to A? How much is it decreased by? From B to A, it's decreased by 8. If it decreases by 8 from 2 and it decreases by 8, I get negative 6. So I'm just saying we do the same thing as we move down both sides. Okay, then it asks me to find the equation of line AB. All right. And who can tell me how to do this? This should be quite straightforward because someone has already worked out for us the gradient of AB. Who can tell me what do we do now if we know the equation, if we know the gradient?
Gradient is negative 1/2.
Yeah.
We will substitute into the equation of y is equal to mx plus c.
Okay, so we're going to y equals mx plus c. Cool. All right. And so which point did you use?
Point B.
Okay. So tell me what you put in here.
0 is equal to negative half into 4 plus c.
Well done.
Therefore, c will be 2.
Okay, so 0 equals negative 2 plus c. Yes, c equals 2. Don't forget, okay, to write the final answer down.
Y is equal to negative half x plus 2.
Well done. Negative half x plus 2. Well done. Okay. Allah. Yeah, I think that was it around. Okay. All right. Okay. Guys, my diagram here is it's getting quite messy now. Okay. All right. I think a really good thing in a maths exam is a pencil and a ruler, a pencil and a rubber, so you can kind of rub stuff out and see. All right. Because the last question now says, I think it's the last question on this one. It says find the midpoint of BC. Okay, can someone do that for us? The midpoint of BC. So I just want the middle of this line here. Anybody?
Because I use the formula which says
Yeah.
x1 plus x2.
Yeah. What did you get when you did that?
X1
Yeah.
is 4
Yeah.
plus 2.
Yeah.
0 plus negative 4 all over 2.
Okay, what did you get for your final answers? Okay. Yes, 4 plus 2 is 6 over 2 is 3 and negative 2. Okay. All right. Okay, guys, we must keep working at our mental arithmetic because we should be able to do that quite quickly. I want to show you something here that I believe is important. All right. So there we used a formula. But what if I said to you, guys, what if I said to you that I want a point between here and here? All right. This point is negative 8, negative 6. And I said to you, I want you to put a point over here so that this is 1/3 of the way along. In other words, if this is P, this is 2P. All right, later we're going to be talking about ratios and stuff. Are we comfortable with how we would find a point 1/3 of the way along the line? Do we get a formula for 1/3 for the mid? If we get a formula for midpoint, do we get a formula for 1/3? No, we don't. I want to show you how we can do this, okay? It's an important idea. How far have I moved when I go from -8 to 4? What's the total distance? Okay. The total change in my x is 12. What's 1/3 of 12? Guys, 1/3 of 12 will be 4. If I add 4 to -8, I get -4. All right? How much have I risen from -6 to 0? 6. What's the third of 6? 2. If I add 2 to -6, I get -4. That point will be 1/3 of the way along the line. Does it make sense? It always makes sense. If I want to go 1/3 of the way from here to the back of the theater, and I know, let's say I know it's 30 meters, then I must just go, what's the third of 30? It's 10. I must just walk 10. Okay, all right. So just be aware of that little trick. Then it says, okay, I think I missed that other question. Yeah, sorry, guys. It says, find the equation of the circle with the center 5, 0, and with the y-axis as a tangent. So I'm just going to draw it over here. 5, 0, is 5, 0 on the x-axis or the y-axis? It's on the x-axis. So I want a circle that looks like this. Center there, but it's got the y-axis as a tangent. Who can tell me the equation of this red circle?
I first calculated R.
Okay.
R as the radius.
Yeah, and what
R
is...
is equals to 5.
R is 5. Okay, and you say calculated, I'm hoping you didn't have to do too much calculation, hey? It's just 5, because it goes from 0, 0 to 5, 0. Okay,
Yes.
5. Cool. All right, then what?
So the equation says x minus 5 whole squared plus y squared equals 25.
Well done. Okay, x minus 5 all squared plus y squared equals the radius squared 25. Okay, all right. Guys, I've realized that something that I've done here, okay, is these questions are mixed, okay? Now, in your exam, all right, that's one of the differences between your exam and the IEB exam. Your exam, all the geometry will be together. All the analytical geometry will be together. All the trigonometry will be together. I'm actually not unhappy that it's mixed like this. I did do it on purpose, all right, because we're getting to see a little bit of everything today. And when you write an exam, you've got to see it all mixed up. So we will come back and do some more data handling maybe later in this document. Okay, let's just keep going. All right, now some trig graphs. Before we dive into trig graphs, I want to show you a quick sketch, and I want to quickly remind you about some things on the trig graphs. Okay? Firstly, all of you should know how to draw a vanilla sine graph, tan graph, and cos graph. This here, the cast diagram, can help me remember, because remember that the cast diagram's in 4 quadrants. Is sine positive or negative at the beginning of its life? Positive. And then in the second quadrant, is it positive or negative? Positive. In the third quadrant, negative. And in the fourth quadrant, negative. This green graph is a sine graph. If I draw with the blue pen a cos graph, does it start off positive or negative? Positive. And then it goes negative. And then in quadrant 3, it is still negative. And in quadrant 4, it's positive. Do you see how this helps you draw these? Okay, right. Now, as we know, there's a whole lot of variations that we can have on our graphs. Okay, I'm just looking for a sketch here. There it is. Okay, There's the vanilla sine graph. What will happen? That graph is just sine x. What will happen if at the back, I add a number after here? I go like sine x plus 1. What will happen? It will shift which way? At the back here, if I go like plus 1, it will shift up. If I go minus 1, it will shift down. Okay. Now for the question that you answered just now, if I add a value inside here, all right, so sine of x plus 10 or x plus 15, what will happen to the graph? Shift which way? Left. Okay, guys, there it goes. That's 15 degrees to the left, 30 degrees to the left, 45 degrees to the left, 90 degrees to the left. Not surprisingly, we have a cos graph, because sine of 90 plus means that we go to our co-ratio. We go to the off the vertical axis. Okay. All right. So that's the left-right shift. If we subtract, the graph goes right. If we add, the graph goes left. What happens if I multiply a number at the front here? If I go 2 sine x, what will change? The amplitude, okay? And the amplitude will get bigger. We are stretching the graph. Cordwa, what if I said negative 3 sine x? Someone tell me, what will happen? Yeah, you're showing me something with your hand. Okay, you're right. It will reflect, guys. If I make it negative, all right, look here, if I make it negative, it goes underneath. If it's negative 1, it's exactly the same as positive 1. Cordwa, it's flicked over the axis, it's reflected. Does it make sense? It always makes sense. If I go negative 2, it's now over the axis and it's being stretched. Okay, and the last one. If instead of drawing sine x, I draw sine 2x, what will be affected? What will be affected if I draw sine 2x, not sine x? Maybe you can show me with your hands. What's going to happen? Yeah, that's going to be affected. The period is going to be affected. If I draw sine 2x, I'm going to get 2 graphs, not 1 graph. The period is actually going to halve, guys. There is sine 2x. The green graph is sine 2x. 1 graph, 2 graphs. What's the period now? 180 degrees. Okay, let's see. I'm looking for answers. I want someone to tell me what these 2 graphs are, F and G.
X is equal to 2 cos into x minus 45.
Sure, like that. Okay, I think that might be a complicated way to do it, and I'm not sure if it's right or wrong. Anybody got a different answer for me? Oh, sorry, no, okay. No, sorry. Ignore everything I said. I think you might be 100% correct, but let's just check. Okay, all right. Yeah. Guys, is this right or wrong?
GHF.
No, wait. Let's just check. Are we happy if this is right or wrong? Guys, is everyone happy that, so, has the period, let's answer some questions about this graph. How long did it take to do a full cycle? 360 degrees. The period has not changed. What's the overall height of this graph? It's actually 4. Do we agree? It's normally 2. So it's definitely, this is correct. Okay. Now, you've said cos graph moved 45 degrees which way? To the right. Okay. A cos graph moved 45 degrees to the right. Yes. Okay. Is there another answer for this? Is there another answer for this? Anybody? Could this be a sine graph? And how much has it been moved, and which way has it been moved? Which way has it been moved? If it's a sine graph, has it been moved left or right? It's been moved left. So there's another answer. Both of these answers are right, guys. Because remember, a cos graph and a sine graph are the same graph. They've just been shifted. Okay, well done. Do you want to tell me the answer for G as well? Or just, okay, please, yeah.
Dx is equal to sine 2x minus 1.
Well done. Halala. All right, excellent. All right, guys, the first thing I'm looking at here, it looks like a sine graph. It's doing 1, 2 waves from 0 to 360. That's why this is sine 2x. Cordwa, the axis is not going through the middle of the graph. If you look at the first one, the cos graph, what we had the same amount of graph over here. With the cos graph, there was like 2 above and 2 below. The axis was going through the middle. But with G, the axis is not going through the middle. So the graph has been shifted down. Right, let's go to some reduction formulae. Okay, I'm looking for answers here. Okay, remember all sine, tan, cos. Well done. Hala. All right, guys. Cos 342 is exactly the same as cos of 18, and it's exactly the same as G. I want to bring up, and I hope I'm not making you tired of all my sketches, but there is no substitute for understanding. Okay, and I want to just quickly show you this in terms of reductions. Okay, if I've got an angle, and okay, now this thing is not going to go to 18 degrees, but I'm going to go to 20 degrees. If you look at the green trig ratios, all right, there they are, for that angle. And remember, it doesn't matter how big the radius is. The trig ratio, the sine of 20, is the same size for all of them. I'm just going to put it back to, 8. I hope I can put it back to 8. Oh, for goodness sakes. Okay, I'll put it back to 10. All right. Okay, now, watch what happens if I put another angle on here. As long as I am 20 degrees away from the horizontal axis. So look at 160. I want you to look at the numbers at the end of point P and point Q. Do you see that those numbers are the same size? They might not be the same sign, but they're the same size. If I go around to 200 degrees, I get those same numbers again. And if I go around to 340 degrees, I get those same numbers again. And that means that my trig ratios will be the same size. Look here. Sine of 20, sine of 200, same size. Cos of 20, cos of 200, same size. If I go to 160 on my angle, I will get the same numbers for those ratios. Not the same signs, but the same numbers. Are we okay? All right. If I go off the vertical axis, I want you to watch what happens. So in other words, instead of going 20 degrees off a horizontal axis, I go 90 plus 20 to 110. Who can explain to me what's happened to the coordinates of point P and Q? I don't want to worry about the signs, just the numbers. Ba, shin, che. They've swapped. Hey? And do you see that sine of 20 has the same size as cos of 110? Okay. Right, let's carry on. I'm looking for answers now for the sine of minus 108 degrees. Who can tell me where are we at minus 108 degrees? Which quadrant are we in at minus 108 degrees? Anybody? Where are we?
It's in quadrant 4.
It's not in quadrant 4. Guys, because it's minus, we're going this way. It's in quadrant 3. Okay. Now I'm going to show you a quick trick as to how we could make this a little bit easier for ourselves. Do you agree that if we are somewhere, anywhere, and we add 360, we're in the same place? If you keep adding 360, you get to the same place. So if I add 360 to minus 108, all right, I get 2, 4, 2. I don't know if it's 2, 4, 2. 2, 2, 5, 2. Thank you. 2, 5, 2. Do you agree that that's easier to see? That's quadrant 3, huh? Okay, what did I do there? I just added 360 to the angle. Because when you add 360, you're in the same place. We're okay now, we're in quadrant 3. I hope you've still got the microphone, whoever gave me that answer. Have you got it? Still? Yes, yeah, carry on. So now, tell me what is it going to be?
I didn't exactly calculate the same way.
Okay.
Sine 0 minus 108.
Okay.
And then I got negative sine 72.
Negative sine 72.
Yes.
Okay. Negative sine 72 is 100% correct. Kodwa, it's not in terms of G yet. Did you keep going?
Yes, I did.
Okay, hala.
Basically, at first I drew a diagram.
Okay.
And then
No, it's all good. Yeah.
I got sine 72 when I drew a diagram. I drew it in the first quadrant.
Okay.
Since it's cos 18.
Okay. Sine 72 is exactly the same size as cos of 18. Okay. So your final answer was negative cos 18. It was negative
G.
G. Well done. Okay. Excellent. All right. Now, guys, well done. Yeah. So for me, at 252, guys, remember, we want to try and involve 18. This is 252, and remember that the 252 is the whole way around there. The 18 is away from a vertical axis. When we come off a vertical axis, sine changes to cos, cos changes to sine. The angle itself is in quadrant 3, so the final answer is negative G. All right, cos 144. Who can tell me about this one? Now, this one's a little bit harder. You'll notice, look at the mark allocation, guys. 1 mark, 2 marks, 3 marks. All right, cos 144. Yes, someone.
So cos 144 is equal to cos 118 minus 36.
Yes. Which is what? Well done.
So cos is negative.
Yes.
We're going to have negative cos 36.
Well done. Okay. I haven't written the step that you told me in. Okay. I'm just thinking, and you're absolutely right. We're in quadrant 2, and we're 36 degrees away from a horizontal axis. Because it's a horizontal axis, I don't change to sine. I leave it at cos, but cos is negative there. Hala. Now we guys, you've got a mark here. You've definitely got you've got 1 out of 3 so far. Now what?
We know that the end says cos 2 beta.
Okay, well done.
When we divide 36, we get 18.
Well done.
So the answer is negative 2g.
Okay, it won't be negative 2g. You've done very well so far. There are 3 different formulas for cos of 2 things. Okay, you guys are going to think Paul's gone mad now. Cos 2 ekaya. The one option is 2 cos squared ekaya minus 1. The one is 1 minus 2 sine squared ekaya. And the other one is cos squared ekaya minus sine squared ekaya. Okay. All right. I'm not mad. Okay. Okay. So, which one, guys, remember, I know about cos of 18. Which of these 3 formulas do you think I should use? The green one, the yellow one, or the blue one? The green one, definitely. The green one only involves cos. Okay, so let's leave that minus sign out there. And what will it be? If I cos of 2, notice we haven't got a k, we've got 18. So it'll be 2 cos 18 minus 1. But what's cos 18? It's g. So there's my answer. Okay, I would give full marks to a learner who stopped here, but maybe it's safer just to take the brackets out. Okay, so if we take the brackets out, we get negative 2g squared plus 1. All right, now tan of 198, someone. Which quadrant are we in? Someone, which quadrant are we in? 1, 2, 3, or 4?
198 equals to 10, 180 plus 18
Yep. Well done. And yep.
equals to 18.
Well done. So guys, that's excellent. And I'm giving you 1 mark. Okay. All right. Now, someone earlier mentioned a little word. Okay. What are you going to do next now?
Equals to square root of 1 minus g squared
Okay. Over.
over g.
Well done. How did you do that though? Can you tell us what you did?
I first drew the diagram.
Well done. So there's a little diagram here with a right angled triangle in. Cos x over r, y over x, r over x. What is it?
It's
Carry on.
adjacent of the hypotenuse.
Okay. Or if we, guys, notice I use x, y, and r because this diagram that I'm drawing could be in the Cartesian plane or opposite hypotenuse and adjacent. Okay. So what goes where here?
One is an hypotenuse.
1 is over here.
Yes.
Yes.
And g is on the x-axis.
Well done. And then this must be? Well done. 1 minus g squared. Hala. Okay. And then what you said is your final answer is tan is opposite over adjacent. So you said square root 1 minus g squared over g. Hala. Okay. Very nice. All right. Okay. We've got time to do 1 more question. Now, this is an interesting question because they ask for the area of a triangle. Oh, I know the area of a triangle is half base times height. Yes? No? Is this good here or not? It's not good, guys. Why not? It's not a right angle triangle. I don't know the height. Okay, this is not good. Okay? So, let's see if someone can tell me how I'm going to do this question. Nancy Kinga. Yeah.
I use the sine rule.
Okay. So, what I'm going to... Well done. Yeah.
AC
Yeah.
over sine 133 is equal to 7 over sine 2.
Okay, well done.
Then I found AC with 40,97.
14,97. Okay, great. So now what we've got, we know this is 14,97. Hala. Now what?
I found that you see the triangle
Yes?
27. I use the interior angles of the triangle.
Well done.
Then I use the area rule.
Okay.
1 over 2
Yeah.
times 7 times 14,97 times 27. Then I told you to 23,78.
How much?
23,78.
23,78. What? Hala. Well done. Okay. Right, guys. Remember that our area rule needs a side, an angle, and a side. I always say it looks like a crocodile jaw with a nyamazan in the Ingwenia's mouth. Okay. All right. That's where the area rule works. The cosine rule, the cos rule also works in that same arrangement. So in other words, if we've got a side and another side and an angle, then we can work out the remaining side using the cos rule, or we can work out the area using the area rule. Okay, right, guys, we're going to here is, sorry, we seem to have lost our ability to. Okay, this one over here, the red one, is just our normal vanilla flavored sine graph. Okay, sine x or sine theta. Okay, this one over here, the green one, is sine 2x. Notice we've got two graphs. I've drawn one so far, I'm now drawing the next one. Okay. Now, when I solve sine theta equals, say, -1/2, like I've got here, how many solutions will I get if I'm talking about the red graph? How many times will sine theta equal -1/2? Between 0 and 360. How many times will the red graph hit that line? Twice. How many times will the green graph hit the line? 4 times. This here is going to affect the number of solutions we're going to get. Now I'm going to show you the way I like to teach this. Your teachers might have taught it slightly differently. What I do, this for me is, guys, this is a vanilla flavored trig equation. It's just a trig ratio equals a number, okay? What I'm going to do is I'm going to get ukiye, a key angle, okay? Lots of teachers will call it a reference angle. I don't put the negative number into the thing here. And I get 30 degrees. 30 degrees is not an answer. It's a key. Which quadrants must I be in if sine is going to be negative? Third and fourth. Now, when I'm solving equations, I will not use the vertical axis. I will only use the 180 and 360 axis. Because remember, if I change off the vertical axis, sine will change to cos. So my answers for this equation are going to be 180 plus 30, Norma, 360 minus 30. This one is in quadrant 4, this one is in quadrant 3. Remember what I said earlier? So guys, these angles are like here and here. If I add 360, I can add 360 as often as I like. All right? But k must be an integer. I can't add half of 360 or a third of 360. I've got to add whole numbers of 360 or subtract whole numbers of 360. Now, I'm very nearly finished with this question. Kodwa, this question didn't talk about theta. It talked about 2 theta plus 10. All right, now, the last thing I've got to do is I've got to solve for theta here. And I'm going to do it quickly, okay, because if you use your brain, it gets better. But I'm going to subtract 10 from both sides, and I get 200. And I'm going to divide both sides by 2. And so I get theta equals 100 plus 180k. And for this one, I get 320 after I've subtracted 10. When I divide by 2, I get 160 plus 180k. I want you to see this 180k that we've got now. Do you agree that's going to give us more solutions than the 360k would give us? And that's because the graph has a shorter period, a smaller period. Okay, right. This here is called a general solution. Okay, and although this question's asking for those answers, I'm now going to use that general solution to find those answers. If I take the first answer and I take 100 degrees, and I don't add anything, that's an answer inside there. If I add 180, I get 280. I can't carry on there. All right? If I subtract 180, in other words, if k is minus 1, I'm going to get minus 80. If I subtract another 180, I'm going to get minus 260. Minus 260 is an answer. Kodwa, it's not an answer in here. So I'm not going to write that one down. Here, I can take 160. I can't add 180 without going outside. I can subtract 180 once, and those guys are my 4 answers to this question. Okay, all right. Really, really important that we know how to solve trig equations. Okay, I think that's a kind of a good approach in terms of solving them. Okay, right. Penduli kasi. Ha. All right. Okay, I'm pleased we've got some geometry. Sometimes we forget about geometry. It's a big topic, guys. Geometry is 40 out of 150 marks. 4 out of 15. Okay, it's quite a lot. All right. This question says, find the size of all these different angles. Okay, I want you to spend 4 minutes, and then I want us to talk about just this question. Okay, so I'm going to write down what we're looking for here. BCD. You guys carry on. Try it yourselves. I'm not doing it. I'm just putting it all on one page for myself. A1, O2. All right, I'm going to ask someone to put their hand up. Even if they've got one of the answers, I'm going to ask Ayanda to come to you, and we will. I'm looking for the first one, for BCD. Someone, if they can tell me.
BCD is equal to 90.
Why?
And opposite. And in a same.
Well done. Remember, guys, I'm not going to play the song. We haven't got time today. But remember that song? Just give me a reason. Okay, I can't sing. You can see why I have to teach maths. If I was a good singer, then I could be going to concerts around the world. But now I have to be a maths teacher. Okay. I love being a maths teacher, guys. All right. Okay. Yes. And if someone's got the microphone for angle A1.
A1 is equal to 38 degrees.
Sorry, just say again. And the reason? Give me the reason again. Radii. Okay, so I'm interested, and I know there are people here who've marked the matric exams. We wouldn't give that full marks, okay? Because I think we need to also say something else. Because, okay. Can you improve on that slightly, anybody? Yeah, so maybe what we could say is OB equals OA radii. Therefore, A1 is 38 degrees. And the reason is angles opposite equal sides. Okay, because what we've said is that this side is equal to this side, and these angles, A1 and the 38 degree angle, are opposite. They are opposite equal sides. Okay, right. I'm looking for well done. I'm looking for an answer for O2.
Angle OY plus angle AY plus angle BY is equal to 180.
Yes.
Using some angles of the triangle.
Yes.
Then angle OY is equal to 180 minus 2 times angle 88.
Yes.
Angle OY is equal to 104 degrees.
Yes.
Angle O2 is equal to 180 degrees minus 104 degrees.
Yes.
Is equal to 76 degrees. The reason was because angles in a straight line.
Okay. All right. Okay. There is. I'm lazy, eh? There is a quicker way. Can anyone tell me a quicker way? That's full marks, by the way. The way you said it all, brilliantly explained, full marks. Okay. Anybody got a quicker way we can get O2?
It's angle at its center equals.
Okay. So, guys, I love maths. I love the fact that there's three different ways of doing this. So O2 is 76 degrees. Someone has said that O2 is 76 degrees, angle at center, and you are 100% correct. Okay? I am going to pull up a sketch just now, but guys, look at this. There off AD, of this arc, AD, there's an angle at the center, and there's an angle at the edge. The angle at the edge is 38, so this one must be 76. There is another reason.
Exterior angle of the triangle.
Well done. The other one is exterior angle of triangle. So I think it's beautiful that there are three different ways to do this question. I do want to show you my angle at center sketch here because I think it's such an important sketch. This sketch here, guys, you've seen it before maybe, but let's just have a quick look at it. Okay, guys, this is like the standard easy version of seeing angle at center. Everyone see it. This one here is the one that this learner has just told us about. Do you agree? It's less obvious to see it. And here's another. So that's flavor number one. That's flavor number two. Here's another one. Some learners say, "Oh, this is angles in same segment. It's like a bow tie or butterfly." Okay, it's not. Because the angles in same segment, they've all got to be on the edge of the circle. That's a third flavor. And then don't forget this one. This angle over here is twice as big as this angle over here. Some learners say, oh, there's a cyclic quad. Okay, that's not a cyclic quad. Okay, right. Then it says, okay, so we've got, what's the last one we're doing? C4. Yeah, I'm looking for help. Yeah, well done. C4 is 33 degrees tan chord. Okay, guys, I know you can't do this in an exam, but I want to show you in geometry what you want to be doing. You want to be able to, in your mind's eye, kind of doing that. Does everyone see tan chord now? And do you see it's easier to see the tan chord now? Okay, because now we've just focusing on the tangent and the chord. So this angle over here will be 33 degrees. All right, well done. Right, let's move on. Pendule kasi. All right. Okay, now, what theorem is this about? Anybody tell me, what theorem is this question about? Yeah, it's about what I like to call the proportional intercept theorem. Some people call it the proportionality theorem. Okay, I'm going to give you a little bit of time to try it. Remember, if you put a ratio on a diagram, use variables. Okay, do not write 2 and 3 on the diagram because we don't know the lengths of the lines. All right, so just have a go at this and then we will talk about it now. Shortly, I'll give you a few minutes. Okay, anybody want to tell me anything that they've done here?
Yes.
Yeah, go for it.
AD over DC is equal to FB over FC.
Okay, so just before you do that, if you don't mind, I'm going to write on here CF to FB is 3M as to 2M. Okay, what I'm showing there is I'm showing the relationship, I'm showing the ratio. Guys, this might be 15 and 10. It might be 30 and 20. It might be 3 and 2. I don't know what it is, but what I know is that ratio, that relationship between the lengths. That's why I'm using the variable. Okay, I interrupted you. Carry on, start again.
AD over DC is equal to
FB as to FC. What's your reason?
proportionality.
Okay, so you're saying the proportionality theorem.
Yes.
Are you saying anything else? I think,
AB
yeah,
parallel to PF.
yeah. I think certainly for the AB, you have to put which lines are parallel. So AB parallel to DF. Okay, great. Okay, and so what is that ratio?
3 over 2.
Yeah.
2K over 3. 2M over 3M.
Yeah. Which is just equal to 2 over 3. Okay, great. So we know, now guys, what I'm going to do now, with that learner's help, I'm going to put a ratio on here, just to remind myself. This is 3K and this is 2K. I can use P, I can use anything. I can't use M. If I say 3M, all right, so for example, if I said this is 2M, then I'm saying that these two are the same size. They're not. I'm saying the relationship between them is like that, 2K. All right. Okay, anybody want to talk to me about now the area of AFD to DFC? AFD. Okay, so we're talking about this triangle here to DFC. Talking about this triangle, and we're talking about this big green triangle here. Oh, no, we're not. We're talking about this triangle and this triangle, sorry. All right. Now, yeah.
Try AFD and try DFC share a common height.
Hala, hala. Sure, yeah. Okay.
Area of triangle AFD over area of triangle DFC
Yeah.
is equal to half over half base times
Yeah.
height.
Yeah.
Over.
Yeah. Okay, all right, so guys, basically it's going to be half base times height, okay? And so it's going to be half 2K times height, and the other one's going to be half. Okay, and guys, I don't like the word cancel, because if you cancel, there's nothing left. Divide. Divide.
Area of triangle
2 is to 3. All right, guys, they have a shared height. This, I was very impressed with that, okay? And when triangles have a shared height, they have their areas in the same ratio as their bases. Now look at those two triangles, the green triangle and the red triangle. Those triangles there, they share a height. Now, you're going to say, Paul, I can't see it, okay? What's helpful is to turn the page so you get the base. Watch what I'm going to do here, guys. I'm going to turn this diagram. Do you now see that they share a height? Where's the height? It's there. But when the diagram is turned, it's not so obvious that they share a height, because that dotted line needs to be the base for you to see that they share a height. When triangles share a height, look at their areas. Have a look what happens here. It's exactly what this guy's just told us. Half base times height, half base times height. The bases are, sorry, the halves divide out, the heights divide out, and because they share a height, their areas are in the same ratio as their bases. Notice if you divide their areas, you get the same answer as if you divide their bases. Okay, very, very nice. Well done. Proud of you. Okay, now EF to FB, Nancy Kinga. Okay, because now we want this little piece here to this piece over here. We want the blue line to the red line. Okay. Yeah?
May I please ask, in that previous question you just did,
yes.
Will that be wrong if I say those two triangles share a side DF and I use that side?
You will be wrong, okay? Because they do, you're right, they do share a common side, but that side has got no importance or relevance to their areas, okay? Unless I think the only way you could then do it is using your area rule for trigonometry. Did you do that? Because I think it's complicated to do it like that. Because, yeah, it's very complicated because these angles are supplementary and, I wouldn't be trying to do it like that. So the shared side is not relevant. Okay, right. Anybody want to tell me how am I going to do this? I mean, this is now, and maybe, guys, one of the things in a test or an exam is what do you do when you don't know what to do? Listen carefully to that question. What do you do when you don't know what to do? Okay? What you mustn't do is do nothing. You must try something. Can anybody tell me another ratio on this diagram? Any other ratio? Any other thing? We've got something equal to something. And I won't say any more. I'll just listen. Any other ratios on this diagram that I can get? Over here, okay, yeah. There are, Ayanda, I'm going to ask you just now to come to the front left here. There's two learners who've had their hands up lots. I know you can't be watching everyone. Yeah. Yes.
So other ratios in the diagram is AD over DC.
Yes.
Is equals to FE over EC.
All right, guys. I'm hoping that you can see that. So what I'm going to do, and I know you can't do this in an exam, I'm going to block that out. And I'm going to block that out. Do you see the parallel lines that we've got now? Now the learner just said AD to DC, which we know is 2:3, is actually going to be the same as FE as to EC. So what we know, all right, is that this is also 2 as to 3. And notice I'm using another variable now. Okay, it's 2 as to 3 because of the proportional intercept theorem. Which parallel lines are you using? AF and DE. Okay, now, Nancy Kinga, because remember what I want. I want the ratio of the blue piece to the red piece. Kodwa, I know the red piece in M's and I know the blue piece in P's. Who can see how we can fix this? Can anyone see where I can convert P's into M's or M's into P's? Yeah, front left here, right down the bottom here. There's two learners next to each other here with masks on, and they've had their hands up lots and lots. All right, guys, I haven't written this one up in terms of this as to this equals that as to that, proportionality theorem, parallel lines, yeah?
CE plus CF equals to CF.
Yes.
Meaning OCF equals to 5P.
5P, that whole line is 5P, yes?
But CF equals to 3M.
Well done, okay. That's this now, we're at the bank with an exchange rate, okay? We've got dollars and we want rands, or we've got rands and we want euros. Now we know how they exchange, okay? Carry on.
Divide by 3 both sides.
Okay, so if I divide by 3 both sides, I'm going to get that. Yes? Okay, and now I know what the red line is. The red line, sorry, I know what the blue line is, 2p.
4p.
And so what's this line going to be the same as? If I change this, if I change 2m into p's, what will it be?
2m equals to 5 over 3p.
2 lots of 5 over 3p, yeah? M is 5 over 3p. So 2m is 2 lots of 5 over 3p. Yes?
Equals to 10 over 3p.
Well done. Now, what will the ratio be if I take the blue piece divided by the red piece? It'll be 2. Carry on.
Can you please repeat the question?
Yeah, so what's your answer going to be for this EF as to FB? What's your final answer going to be?
EF equals to 10 over 3p.
Yeah. And FB? Oh no. EF's not 10 over 3p. FB's 10 over 3p.
Oh, it's 5 over 3p.
Yeah. Okay, so this is, let me just do this. This is, okay, goodness, sorry guys, messing this up a bit. Okay, so it's 5
over 3p.
for which one?
EF.
No, EF is 2p. EF's 2.
EF equals to 10 over 3p. Then EF equals to
You've done all the hard work. I think, I don't know if I'm getting confused or if you're getting confused, but look at this. EF is 2p. FB is 2m, but m is 5 over 3p. So FB is 10 over 3p. Yeah, that's it now, okay? Now,
equals to 3 over 5.
yeah, well done. It does equal to 3 over 5 in the end because, guys, divide and divide. Now we're dividing fractions, hey? 2 divided by 10 over 3. Remember how we divide fractions? We tip and times. We get 2 times 3 over 10. We get 6 over 10. We get 3 over 5. Right, guys, this topic here is probably the thing that people find the hardest in all of matric maths. Okay, it's not easy. All right. Okay, well done. Absolutely. All right. Okay, now, what can anybody tell me about these two shapes? Can anyone tell me anything about these two triangles just by looking at them? They are similar. Yeah, they are similar. Okay. Now, I want to remind you something about similar figures. Okay, and I'm going to ask you a question which everyone always gets wrong, and I'm going to see if you guys are going to get it wrong or if you're going to get it right today. Okay? If I've got these two rectangles, okay, I've got a red one and I've got a green one. Okay? And I want you all to shout, when I ask you, I'm going to ask you to kind of shout out the answer. All right? I'm going to ask you just to tell me how many times bigger is the green one than the red one? How many times bigger is the green one than the red one? Shout out the answer. Ha la, you all got it wrong. Horror, you all got it wrong. All of you got it wrong. Okay, guys, this one has an area of 6 This one has an area of 24. Okay. The sides are twice as big. Cordwa, this red rectangle will fit in here twice across. Okay, because it will fit in with a 3 and a 3. Am I right? Cordwa, it will also fit in twice over here, because it will fit in with a 2 and a 2. So how many little red rectangles are there in the green rectangle? 4. Okay. Now, here's the thing. Here's the sketch, okay? If your scale factor is 2, so your sides are twice as big, then you square that to get the areas. Okay, do you see that? So if I make the scale factor 3, the areas will be 9 times. 3 squared, 9. Okay. This applies to all similar shapes. It's easy to see with a rectangle. It's not so easy to see with like a weird shape like that, but it's still true. The sides here are twice. Okay, let me just make the scale factor 2 again. The sides here in the grey figure are twice as big as the sides in the blue figure. Okay, this one looks white on the screen there. On my screen, it looks grey. Okay, so because of that, the areas will be 4 times as bigger. Now, let's see if we can answer this question now. Okay, it says that this one is 2 1/4 times bigger. So we could actually write, 2,25 P, and this is P. Okay, so, guys, the ratio of the sides, okay, if we take the ratio of the sides, like if I take AN from this one, what must I divide it by in the other one? AN over BH. Look where AN is. AN is opposite the 41-degree angle. The side that's opposite the 41-degree angle, and this one is BH. Okay. Now, AN over BH, I don't know what that is, but I do know that when I square that, I will get the ratio of the areas. Okay, I will get P over 2,25P. All right, listen carefully. To get the ratio of the areas, we square the ratio of the sides. Okay, so now if I divide the p's out, I get 1 and 1. All right, so AN over BH is 2,25. Can anyone tell me what is 2,25 as a mixed number? 2,25 is 2 1/4, it's what? 9 over 4. Okay. All right, so who can tell me when you go 1 over 9 over 4, you actually obviously get 4 over 9. What should I do to both sides now to find AN over BH? Square root both sides. So in fact, guys, AN over BH is 2 over 3. So if this side here is like 2m, this side over here is 3m. This side over here might be 2g. It's opposite the 56-degree angle. So 3g and 2g. And maybe 3h. Sorry, 2h and 3h. Those triangles are similar. It doesn't matter how you divide the sides, you get the same ratios, 2 as to 3, but the areas are not 2 as to 3. The areas are 2 as to 3 squared. Okay, right. Okay, now this question asks us to find the standard deviation of these numbers. I'm actually not sure if we're going to do this question. We're going to leave that question, guys. We're going to leave that question. I want us to go to question 6. because I did do some standard deviation stuff earlier. I want everyone to try this question. It's 6 marks. It's quite a lot to be done. The worst thing you can do is to do nothing. Okay, if you do nothing, you're going to get nothing. Even if you just think, I'm going to try something. Okay? All right. I'm wondering if anyone here has got an answer for us. All right, so there's the picture. I'm wondering if anyone here has got a final answer for us. Okay, we've got a final answer here. So I'm just taking the final answer. Now, guys, what if this learner has got this right? Okay, I'm going to type the equation in. If they've got it right, we will have a tangent. It won't cross the circle twice. It won't miss the circle. Give me your final answer. And then I'm going to ask you how you did it. But I'm only going to ask you how you did it if your answer is right. Tell me your answer.
Y is equal to 7 over 4x minus 6.
7x over 4 minus 6. Halala! There it is, guys. You see it? All right? It is correct. Okay? It is correct. So let's now tell me, what did you do?
Firstly, I determined the points of the center.
Okay, so you put this into standard form. Can you tell me how you did that?
X squared plus 6x plus 9. I have the coefficient
Yep.
of x and squared it and added the 31.
Yeah.
So I had x squared plus 6x plus 9 plus into y squared minus 10y plus 25 is equal to 65.
What's this one going to be?
Minus 10y plus 28. So it's y minus 5 squared.
Yes, plus 25 equals 65.
Yes.
Right, so what's the center?
Minus 3 is to 5.
Well done. Minus 3 is to 5. Okay. All right. So, guys, yeah, I'm hoping that you're comfortable with completing the square. What the learner said very nicely is we halved that. Okay. And the reason we halved that, okay, is because when we square, it gets doubled. We halved the 10, the minus 10, to get minus 5. Okay. But when we multiply these things out, on the left-hand side, we have actually added 9 that wasn't there before, and on the right-hand side, and we've also added 25. Nancy Kinga, our scales, our set of scales, which is what we use to represent an equation, is not balanced. So to fix that, we have to add 9 to the right-hand side, because we added it in on the left-hand side, and we had to add 25. All right, great. Now what did you do next?
I determined the gradient of the radius.
The gradient of this radius. Is it positive or negative?
It's negative.
What is it?
Minus 4/7.
It's minus 4/7. Okay, well done. Guys, look at that. It's dropped down by 4, and it's run across by 7. Rise over run. Okay, then what did you do?
Because I know that the radius is perpendicular to the tangent, it means that the gradient of the radius times the tangent equals to -1.
Okay, well done.
Then the gradient of the tangent is 7/4.
Well done. Okay, all right. And then?
And then y is equal to 7/4x plus c, and then I substituted point A. 1 is equal to 7/4 into 4 plus c, and c is 6.
Well done. And then final answer, 7/4 x minus 6. Halala. Okay. All right. Okay. Then it says, now we've got the same circle, okay? And so we've got a circle, and this is the point, we worked that out just now, you said that was -3, 5. And now we're drawing a tangent from the point 12, -4. All right? 12, -4. Now, guys, 12, -4 is going to be down here somewhere. How many tangents can I draw to this circle from this point? 2. Does it matter which one I draw? What do we know from circle geometry? They're the same length. So it doesn't matter which one. Okay. All right. This line here would be the same length as this line here. Can anyone tell me how on earth are we going to do this question? Because we don't know what that point is, and we can't work it out. And we don't know what this point is, and we can't work it out. Okay. Can anyone tell me how else can I find how long these tangents are? Okay. So this is D. We'll just do the red one. This is point B, and this is point D. Yes. No. Yes, over there with the jersey. I know there's 2 guys with their hoodies on, like the one I'm not sure can even see. Yeah. Next to you. Yeah. Your friend there, I don't know, I think maybe Ulele. Ukatele. Okay. Next door there. Yeah, right next door. Yeah, there we go.
The distance from B to the center of the cell.
Okay, this distance here. Okay, I'm going to call that L. Okay, all right. Yep.
And the distance is 3 roots, 34 units.
The square root of 34. No. 3. 84. 34. Sorry. Okay. All right.
The distance from the center to D.
Let's call that O to D. Yep.
O to D is a radius, and from the previous question, we saw that it should be equal to root 65.
Well done, guys. That's the square root of 65. That's the radius, and that's exactly right. That's what the learner above said. 65. So square root of 65. And now what can you do? Well done. Okay, because there's a right angle here, guys, we can use Pythagoras. So BD squared will actually be OB squared minus the radius squared. Huh? What did you get as your final answer for BD? Well done. It's square root of 241. Guys, it's about 15,5 units. Well done. Okay, excellent answer. All right. I'm looking now. Okay, there's a cool question. All right. This is a really interesting question. Find this angle theta. Okay. All right, guys, whenever... Okay, the first part's easy. Let's just do the first part together. This dashed line has got a gradient of... And guys, the way I would do this, how much have I risen? I've risen by 10. How much have I run across? By 8. The gradient is 5/4. Okay, now, do I know the gradient of this line? What is the gradient of this line? It's not 2. Yeah, guys, it's not in standard form, hey? It's not 2. It's actually y equals negative 2x plus 3. So its gradient is actually negative 2. Now, whenever I do angle of inclination, all right, I'm going to use angle of inclination here because look at this word here. Work out the gradient, hence, using what you've just done, find the size of theta. Now, guys, I'm going to put, do you remember my angle of inclination sketch? I'm going to find it for you quickly if I can. I've probably still got it open. There it is there. Do you remember, it doesn't matter where I put the horizontal line. You remember that? Okay, the horizontal line can go anywhere. Watch where I'm going to put the horizontal line here. And now I want you guys to try and do this question. If I put the horizontal line going through there, see if you can work out some angles here, some angles of inclination. And I'm going to give you some names. I'm going to call this angle here alpha. I'm going to call this angle here beta. And I want you to see if you can work out theta. All right, anybody want to have a go? No? Have a go, yeah? I'm using color here everywhere. Guys, this is a green line. This green dashed line, green. Luhlaza Jengochani, is it? Jengochani. Okay? And then if I battled with that, I'm going to battle even more here. Luhlaza Jengesibaka Baka or so. Am I right? Can someone say to me, Ingashu Kanjani Uguti, blue like the sky in Gesizulu? No. Like the sky. Say it again. Luhlaza. No. What like? Okay, you want the green one? Okay, all right. I'm trying to learn Zulu. Now's not a good time to learn Zulu. Okay, right? Yeah. Yeah.
theta.
Okay.
Or
Alpha.
alpha.
Yeah, not actually. We've actually got this. These are the wrong way around. Remember, you're not going to find the tan of the...
Tan of alpha.
yeah, halala. Okay, so...
Alpha is equal to 51.34 degrees.
okay, cool. All right.
Alpha plus theta is equal to 180 degrees, raising angles.
No, alpha plus theta is not 180. Can we get beta? Can we get this blue angle beta? Because this blue angle, guys, is the angle of inclination of the blue line.
Beta is equal to theta plus alpha.
Correct. Yeah, correct. Beta is equal to theta plus alpha. Norma, theta is beta minus alpha, isn't it? Theta is beta minus alpha. Yeah. Okay. What is beta though? Are we going to get beta if we know the tan of beta is minus 2? Octan, yeah. Octan minus 2, okay. If you go octan minus 2, I'll tell you that you get minus 63,4 degrees. Okay? So what size is beta then? Okay, well done. So beta is 116,6 degrees. Okay? All right, so it's going to be 180 minus that. Yeah. Okay? And so the final answer?
116,57
Yeah.
minus 51.2 is equal to
What's it equal to? 65.3 degrees. Are we okay, guys? Okay, well done. All right, so let's, guys, I'm just looking because we're definitely not going to be able to do everything today, and that's not actually kind of a problem. But let's do this question, okay? Because I think this is an interesting question. Those two triangles, and I'm going to call them the blue triangle, all right, and the green triangle. What do those triangles share? And we've seen this already today. Well done. They share a height. Guys, that height, if you turn your page slightly, you'll see that height. That height is somewhere in there. They both have the same height. Now, if their areas, listen carefully, if their areas are 1:2, so I'm going to write here A for area, 1A, and here I'm going to write 2A for the area. Okay? I made this question up. I like this question because it really tests some understanding here. What do I know about the ratio of AB to BC? If the heights are the same, what must this here to this here be? It must be the same as the ratio of the areas. Are we okay? If the areas are the same, so if the heights are the same, the areas are on the same ratio as the bases. So do you agree if this is P, what must this be? 2P. Now, okay, and the question is asking, what are the coordinates of this point? Now, guys, who can tell me in words, how far along the line from A to C must I go? I must go 1P out of 3P. I must go 1/3. And remember what I said earlier, guys, if I want to go 1/3 of the way, all right, let's have a look at how we're going to do that. What's the change in my X value from A to C? When I go from A to C, what happens to my X value? How much does it grow? 15. What's 1/3 of 15? It's 5. Now guys, if I take 2 and I add 5, what do I get? 7. What is 2 lots of 5? It's 10, hey? If I take 10 off 17, what do I get? I get 7. Does it make sense? It always makes sense. Okay, what is happening to my y value here when I go from point A to point C? How much is it growing by? Also 15. Okay, and 1/3 of 15 is 5. So I can either start here, I can add 1 lot of 5 and I get 6, or I can start here and I can take away 2 lots of 5. 2 lots of 5 is 10 and I get 6. Okay, do you see? Now guys, you don't get a formula. You do not get a formula for 1/3 of the way along a line, but you can work it out. Okay, all right, it's a cool question because it mixes in some very different bits of maths. It mixes in Euclidean geometry and areas of triangles with shared heights. It also mixes in some analytical geometry. Wait, man, hi, bo. Look at this graph. Even Ma'am Nele and Mr. Zimamba, they've been teaching maths for a long time. Hey, they haven't seen one like this before. Okay, all right. Guys, that's the equation of this graph, okay? But now, don't be scared. Let's look at this. Let's look at this carefully. It says, what is the period of this graph? Now, what does the period mean? It means how long does it take before it repeats itself? And what is the answer to that? It's 360 degrees. Okay, and the reason it's 360 degrees is from here to here. Do you see? From there, it just repeats. So this distance here is 360 degrees, and that's the period. Is this a fair question or an unfair question? It's unusual. I don't think it's unfair, because if you understand what period is, then you can answer this question. Then it says, find the general solution for these points here, the x-intercepts. How do you find the x-intercepts of any graph? You make y equal to 0. So guys, what we're trying to solve here now is sine theta minus cos 3 theta equals 0. All right, now, this is the same as saying sine theta equals cos 3 theta. Listen carefully to what I'm going to say now. In trigonometry, when you've got sine and cos in the same equation, there are 2 types. If you've got something like this, there's a strategy here. The strategy for the red one is not going to work for the black one. Who can tell me, what can I do with the red one? The red one's easier, I think. Yeah, there's an answer right here. What can I do with this red one?
You can divide by cos of theta plus 10 degrees on both sides.
And what will I get?
Sine of theta plus 10 degrees equals 2.
Well done. Hala. Guys, do you agree? That's now much better. Okay. All right. But the difference, guys, is that trick going to work here? No. It's not going to work here, because when you've got sine theta over cos 3 theta, it's not tan. Okay. Who can tell me, how do I solve a trig equation when I've got sine of something equal to cos of something else? At the back there.
I think we have to change cos into in terms of sine.
Well done. How are you going to do that?
It's sine of 90, but then it's minus or plus.
90 plus or 90 minus? Guys, we always use minus, okay? Because remember, if when we go 90 minus, we're going into quadrant 1, and sine and cos both positive. So we don't want to change the sign. Okay. All right. Now, yeah. Okay. Tell me what you're going to do next year, because guys, this is probably one of the hardest things to explain and understand in matric maths as well. Okay, but carry on.
I think we should divide by sine also.
Yeah, you're not actually dividing by sign, you're undoing sign. But anyway, yeah. So you get what? Yeah, drop the signs. Okay, so you get theta is 90 minus 3 theta plus 360k. All right. Now what are you going to do? Okay, solve for theta. So we get 4 theta equals 90 plus 360k. Divide by 4. Theta is 22.5 plus 90k. Okay, well done. Kodwa, you're missing some answers here. All right? You're missing some answers because, and I'm going to explain this. There's some other answers here. All right? Just listen very carefully now. If we've got sine theta equals sine 20 degrees. So this is a simpler question. Does everybody agree that theta could be 20, or we could have theta equals 20 plus 360? Is everyone okay with that? Yes, I think that's fairly obvious. Kodwa, there are other answers that we're not getting. And I want you to think of your cast diagram. Which quadrants is sine 20 positive or negative? Positive. So there's answers in here, and there are also answers in here. Who can tell me what is the other possibility here? Because this is 20 degrees. What's the other possibility? And I want you to think back to that trig board that I had. What's the other possibility here? Norma, what's the other thing we can have? Guys, where else will I get exactly the same? I'm going to go back to this thing. All right, if I can find it easily. Yeah, there it is. Okay. There it is. Guys, look at this. There's 20. Where else could I make this red angle to get the same answers? At 160. Guys, do you see that at 160, I get exactly the same value as I got at 20? And so the other possibility here is that theta could be 160 plus 360k. And so the answers that you haven't got here is when you went theta is 90 minus 3 theta, you could have and should have also said, or theta is 180 minus 90 minus 3 theta plus 360k. Okay, and guys, people find this really, really hard. Okay, this, if you simplify this one, okay, you get theta is 90 plus 3 theta plus 360k. So you actually get minus 2 theta is 90 plus 360k. And then you're going to get, when you divide by minus 2, you're going to get theta is minus 45 plus 180k. It's actually minus, it doesn't really matter if you put plus or minus here, because k can be plus or minus anyway, but let's just put minus. It's sort of mathematically a little bit better. All right. So guys, that piece there and that piece there is your general solution. All right. And you can go and work out, if you go and look at the x-intercepts, those are exactly what they are. Now, I want you maybe just as a summary for yourself. I know on the back, I think on the back of your document is page 24, on the very back, is it blank? Is it empty? Or is there stuff written on page 24? Oh no, you've got page 28. Okay. On the very back cover, write this down. if sine of A equals sine of B, then A equals B plus 360k, or A equals 180 minus B plus 360k. So those are your two options. If you've got sine equal to sine, then either the angles are equal, or one of them is 180 minus the other one. Okay. So, and that happens when you've got different angles. So you can't divide to get tan. Okay, next up is a trig identity. I love trig identities. All right? The reason I love trig identities is because we will always know if we are right or wrong. I'm going to give you guys a few minutes to try it. Okay? Remember, we don't work with both sides together. We don't put them equal to one another. We say left-hand side and right-hand side. Okay, you can do that. You can work with both. Have we got an answer already? Someone got the microphone ready to go? Okay, just hear my gun. I just want you to give 2 minutes for people just to try. I will give you a hint. On the left-hand side, there are two terms. On the right-hand side, Elilodwa, there's only one term. Right, let's have a look. Yes.
So I choose the left-hand side.
Yes.
Firstly, I made the denominators the same.
Okay.
So I have sine theta into cos theta plus tan theta.
Yeah.
Plus sine theta into cos theta minus tan theta.
Yeah.
Cos squared minus tan squared.
Cos squared theta minus sine squared theta. Okay, hala. All right, very good. So what we've got here, you've added those two fractions. Now, yeah, guys, remember, and I've spoken to you about this many times, you need to learn your identities. Okay, carry on.
In the numerators, I now have 2 sine theta cos theta.
In the numerators, you've got 2 sine theta cos theta.
Yes.
Okay, you might be saying, where's this? What else have we got? The sine squared theta and a minus sine squared theta. So that's exactly right. Yeah.
Over cos squared theta minus sine squared theta.
Yeah.
Then 2 sine theta cos theta is equals to sine 2 theta.
Well done.
Then cos squared theta minus sine squared theta is equals to cos 2 theta.
Well done.
Then that equals to tan 2 theta.
Okay, well done. And then I think it's quite a good idea to say equals right-hand side as well. Okay, very well done. Okay. All right, now guys, we keep saying this word. I've told you what this word means. It says, using what you've just done, solve this equation. Now this equation, hey, it's not nice. Cordwa, we know that this is tan 2 theta equals minus 1. Okay. All right, guys, I'm going to show you how I would solve this equation. I would find ukiye. When I find ukiye, I undo tan, but I don't do the minus 1. I just get 45 degrees. This is not an answer. Guys, which quadrants do I want to be in for tan to be negative? Second and fourth. Now, look at the picture here. The one in the second quadrant is going to be 180 minus my key. And the one in the fourth quadrant is going to be 360 minus my key. These little red dots are my key. And do you see that for tan, these angles are on a straight line? So, the nice thing with tan is my answer is just going to be one of those answers. I'm going to go 180 minus 45. I get 135 degrees. But now I can say plus 180k. And the reason it's 180k is because if I add 180, I get this answer. If I add another 180, I get the repeat of that answer. Cordwa, now don't forget, this is not theta, this is 2 theta. So what must I do now? I must just solve for theta. So theta is 67.5 degrees plus 90k. Okay, that's the general solution, and now I can get my specific ones. If I take 67,5 and I don't add anything, that's what I've got. If I add 90, I get 157,5. If I add another 90, I get 247, it's too big. If I minus 90, I get minus 22,5. If I minus 90 again, I get minus 112,5. If I minus 90 again, I get a number that's too small. Okay. All right. Maybe you couldn't do this identity. Doesn't mean that you can't do this question here. All right, so just be aware of that. Okay, right, let's have a look at this question. It's got no scaffolding. It doesn't suggest what we should do here. All right? Anybody got an idea? And I don't want you to solve the question. I just want you to give us a start on what might this have come from. Well done. I'm hearing it. It looks like it might come from similarity. So this is a tricky question because it's not telling us what to prove similar. But maybe there are some triangles in this diagram that are similar. Okay, and you can even go just by do they look similar, all right? But also look at what lengths are involved. Can anybody tell me what triangles they think we should maybe prove similar? Yeah, so we've got some answers. I don't know where. Yeah.
Triangle data similar is ABC and ACM.
A, B, C, and ACM. I don't think so. Are they? Yeah, they might be. They might be. A, B, C. Yes, they are. They are. Okay, so this one here and this one here are this one here and this one here are similar. But if you can prove those two similar. All right? And the reason, guys, the reason they're similar is because obviously this is this is an isosceles triangle. All right? So this angle over here is equal to this angle over here. But this angle over here is also equal to this one for tan chord. Okay. But, guys, I don't think those triangles are going to be helpful. All right. Because, can anyone tell me what else is similar? So which one? MDC, this one. Guys, this little blue one, and which one?
Triangle CMD and triangle ACD.
Well done. Okay. Those two triangles, guys, are going to be similar. That one and this one over here. All right? That one and this green one. So the blue one, the blue one and the green one. Okay. Can you tell me why those triangles are similar? Anybody?
NVD or triangle CMD
Yeah.
is common to NVD on AC.
Okay, so this angle over here is in both triangles. Yeah. What other angle have we got?
C3
Yes.
is common to
It's not common, but what's C3 equal to? Yes, why? Well done. C3 equals A2 tan chord. Okay? Now, guys, remember we need three angles, but actually, if we've got two, the other one must be. Yeah. Okay. So what is the other angle in the blue triangle? Which angle have we not spoken about yet in the blue triangle? M1, okay?
is equal to C2.
It's actually C2 and C3, or A, C, D, if we want to, okay? And this is third angle of triangle, okay? All right. Now, so therefore, listed in the correct order, what's similar to what?
Triangle CMD is similar to triangle ACD.
CMD, similar to, okay, guys, we started at C, so we can't start at A. We can't start at A if we went, oh, sorry, absolutely, A, sorry, I'm in the blue, I'm talking about this little angle here, so I must go to that angle there, yes. A, and then what? Then to C, and then to D. And what's your reason here? Angle. Okay, right. Well done. Now, if they're similar and you've proved them similar, keep the microphone. Can you pull out a ratio for us here?
CM over AC
Okay, guys, look at this. CM over AC
is equal to MD over AD over CD
MD
over CD
over CD
is equal to CD over AD.
equals CD over AD. Okay, I think maybe we don't need this first one. Am I right? Okay. What's the reason for this? We've got to have a reason, guys. Yeah, the reason we can do that is because we've got similar triangles. And now what's the last thing we're going to do? Almost, last thing.
We're gonna
Cross multiply, so we get CD squared equals DM times AD. And that's what we were asked for. Okay, well done, very well done. All right. Then they ask us to prove that dm over ma is dc over cb. dm over ma is dc over cb. All right, now guys, this is an interesting one. All right, because I think there's more than one way of doing it. But look what they're asking us to do. They're asking us to prove, guys, look at this. They're asking us to prove this over this is the same as this over this. What does that look like? It looks like our proportionality theorem. Do you agree if these lines are parallel, then we've done it? Okay, so can we prove these lines parallel? Who can tell me how to prove these two blue lines parallel? How can I prove those two blue lines parallel? Let's have we got the same person with the microphone or not? Can we change? Did the microphone change? Sorry. It has. Sorry, carry on. Sorry. Angle A1, yeah. Angle A1 is equal to angle M2. Why? Well done. Tan chord theorem. Yeah. Yes. Why? Yes. 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 Okay. All right. Well done. And therefore that over that will equal that over that because of proportionality. Okay. Very nicely done. All right. Okay. Right. I'm just looking. Yeah. We haven't done something like this. Okay, guys, I'm going to leave that. I'm going to go to question 9. We might well come back to it. We might well go back to question 8. I'm going to go to question 9. All right. All right. And so we've got, let's just read this. We've got a vertical tower. So this is vertical. And then points A, B, and C are in the same horizontal plane. So this is all on the ground. Okay, this is Uchani that I'm drawing here. This is grass. Okay, I want you guys to try this question. Some people struggle with these questions. It's often then helpful to draw the different triangles on the side here in 2 dimensions. I think when I've taught you guys this before, I've used one isiZulu word that I'm very proud of because I think Mam Lele told me the word. Can anyone tell me what that word is? Nice and loud. I, bu, lo, cho. Is that right? Is that right or not? No. How do I write it? Oh, yeah. IBH. EB. Ibu. E. Is that right? L-O. H-O. Ibuloko. Okay. Ibuloko. Okay, there we go. Ibuloko. All right. Okay. All right. And it's a bridge. Okay. This line over here, I call it a bridge because it's a bridge between the green triangle on the floor and this blue triangle that's up here on the side. Ibuloko. Guys, if you write nothing, you're going to get nothing. All right. So I'm going to start off here and I'm going to say the sine of alpha is equal to dB over, no, I'm not going to say that at all. I'm going to say the tan of alpha. dB over AB. So dB is AB tan alpha. Guys, even if you do that, is that all correct? Tan alpha dB over AB, that's correct. You're going to get some marks. All right. But I don't know about AB. Who can tell me how to do this question now? Yeah, all right. Okay, so this angle over here is 180 minus 2 alpha. Yep, okay.
D over sine 180 minus 2 alpha. Is equal to AB over sine alpha.
Okay, so guys, if we have a look, what's really nice here, that is Ibuloko, all right, and there it is over there, down there, Ibuloko, this line here. Okay, all right, okay, carry on.
AB is equal to
Yep.
AB is equal to D sine alpha over sine 2 alpha.
Okay, so you cross multiplying. AB is D sine alpha. Now you said over sine 2 alpha. And you're 100% correct. That is a reduction, guys, because remember, if we are in quadrant 2 or for horizontal axis, sine of 180 minus 2 alpha, sine 2 alpha. Carry on. Wonderful.
Sine alpha is equal to dB over AB.
Yes. Okay, which I've got here, yeah.
AB is equal to dB over sine alpha.
Yes. So A
AB is equal to
AB
dB over sine alpha.
is this is AB, sorry. Okay, and another problem here is that I don't seem to have an eraser anymore. What on earth is going on here? Oh, there it is. Okay. So this should be A, B. Okay, so tell me what to do now.
AB is equal to dB over sine alpha.
AB is equal to
dB over sine
dB over tan alpha, okay?
and then d sine alpha over sine 2 alpha is equal to dB over sine alpha.
Okay, so sorry. So d sine alpha over sine 2 alpha is equal to dB over tan alpha. Yeah, okay.
dB is equals to d sin alpha over 2 sin alpha cos alpha times.
Sure, okay. So dB is going to be, I'm struggling here. dB is going to be this stuff, d sine alpha over sine 2 alpha, and then times tan alpha. Yes, okay, carry on, sorry.
D sin alpha over
Yes.
over 2 sin alpha cos alpha.
Okay, so this is now our double angle. Sine of 2 alpha is 2 sine alpha cos alpha, yes.
Times sin alpha over cos alpha.
So tan is sine alpha over cos alpha, yes. And
Sin alpha will divide sin alpha.
yes.
Then what we left is d sin alpha over 2 cos squared alpha.
Allah, well done. Okay. Okay. All right. Now, guys, this in any exam, we can have like a problem-solving question at the end. Okay? And this topic is called geometry and measurement. All right? Now, this question, I put this question into an exam here at school, and just about nobody got it right. Okay? Let's just talk about it now. So what's happening here, and I should have brought a piece of paper, a round piece of paper. If you cut a piece out, like a slice of cake, and you fold it, you will get a cone. All right. So you pull it towards itself, you get a cone. Okay. Now, okay, let's see if we can work out what it says is what is going to be the size of the angle which the sides make with the base. That's what we're trying to find out. Because I think you guys know we get lots of different types of cones. You get one like that, and then maybe you get one which is much like that, and the angles will be different. Okay. All right. Now, what we've got to do here, we've got to think about if we knew in this diagram, okay, this diagram is when it's not folded. This diagram here is when it's folded. Does anyone know, can anyone tell me what is this length here going to be the same as? Maybe it's hard for you to visualize. Okay? I'm going to look for something on my phone while you guys just try and think about it. Won't find it in monthly some days. No, I'm not going to be able to find it. Seriously. Okay. I cannot believe it. I have found it. Okay. All right. Guys, just have a look here because maybe this will help you. All right. And I don't want to spend too long on this because the chances of you getting this question exactly are very, very close to zero. We'll do probability next week, but probability of this question is very close to zero. Okay. But just have a look at this video here. Okay, cool, just hold it like that. Okay, so what we've got here, we've got a circle with the radius of r, and we've cut a sector out of it. If we fold it like that, do you see that? Then what we get is plant height, which is equal to the radius of the original circle. Do you see that, guys? Okay. I don't know if you can really see it very easily. Okay, all right. Okay, so I can't believe I found that video. Okay, guys, this length here, when you join it together, this is R. Okay, and so we know what that is. Okay, do you agree that if we knew this side here, then we could work out the angle using cos, okay, adjacent and hypotenuse. All right, now, guys, what if this is the radius, the circumference of the whole circle, okay, the circumference of the whole circle is 2 pi times radius, but we've taken out a portion. We have taken out 60 degrees out of 360 degrees. So this is 300 and that's 360. So when we take that piece out, our circumference of the bottom here is actually, it's 5/6 of 2 pi r. All right? I don't know if people are following that or not, but this piece, 1/6, is missing, so 5/6 are left. All right? That's the circumference. How do you get from circumference to radius? Remember, circumference is 2 pi r. So radius, if we divide both sides by 2 pi, radius is 2 pi is circumference over 2 pi. All right. And that, guys, that then enables us, I'm not going to carry on with this, but that enables us to work out the radius of this, because if you divide this by 2 pi, all right, then this will divide, and this length here is actually going to be 5/6 of r. And it doesn't matter that you don't know r, because when you divide, you're going to get a number which you can then use the arc cos. Okay, let's leave that. I probably shouldn't have included that question because it's unlikely to come up. Let's look. I think this might be the last question that we need to look at. All right, and it's this one over here. It's quite a complicated diagram. All right, it's on your page 20. So we're on page 20, and I'm going to give you some time just to have a look at it and to try it, and then we'll take some answers. Okay, guys, when I look at this question, I'm told that this is a diameter. We're going to need to use that for sure. And as soon as you read that, we ask ourselves, what do we know about diameters? Anybody tell me one fact about a diameter? Yeah, just you can say it nice and loud without the microphone.
The angle that makes the circumference is 90 degrees.
100%. Okay, well done. So we know about right angles now. Okay. All right. Now, guys, we're being asked to prove, listen carefully, we are being asked to prove that punk, this shape here, punk, is a cyclic quadrilateral. Now, how many ways have we got of proving that a quadrilateral is cyclic? Okay, I want someone, and I'm hoping Ayanda can bring a microphone to someone. I want someone to tell me all 3 ways by which we can prove a quadrilateral is cyclic. Okay, I want, as I under not here. Okay, all right, just tell us nice and loudly. Yeah. Yes. The converse of the angles in the same segment, yes. Correct. Okay. Yeah, and the last one, well done. Okay, right, guys, look at this. Here, I've got a sketch that if I make, I can choose the size of this angle. Do you see that I've got the opposite angles are supplementary, and I've got an exterior angle. There will always be a circle through those 4 points. Okay, so it doesn't matter where the points are, all right? As long as the exterior angles equal, I'll be able to put a circle through those points. In other words, it's a cyclic quad. The first one that you mentioned, all right, is this one. Okay, and I'm just going to look because I found. Guys, look at this here. So here I've got a sketch. I've got a sketch where I choose an angle here, and these two are the same, and those two are the same. There will always be a circle through those points. All right, because if there was a circle, these angles would be equal because they're in the same segment. Because they're equal, there is a circle. All right, okay, now, who would like to tell us how to do this question? So there's the question. We're trying to prove that this little green thing is a cyclic quad. Ayanda's going to come and find someone.
SKT is 90 degrees.
Sorry?
SKT is equal to 90 degrees.
SKT. And your reason for that?
Angle subtended by diameter.
Correct. Okay, great.
Therefore, NKP is equal to 90.
So this is 90 here. Yes. Okay, because it's on a straight line, yes.
SUT is equal to 90 degrees.
Why is SUT equal to 90 degrees?
Because it's also angle subtended by diameter.
Okay, it's also subtended by a diameter. Yep.
Therefore, PUN is equal to 90.
Yes, you in fact don't even need it because you could use your exterior angle, but yes. Okay, yeah. All right. Okay, and so in which case, so you then saying that's 90 and therefore? Okay, so I'm just a little bit nervous about the last part of what you're going to say now. Are you going to say that the opposite angles are supplementary because it's a cyclic quad? Or are you going to say it's a cyclic quad because the opposite angles are supplementary? Okay, well done. All right, guys, so let's just quickly write that down. Okay, well done, absolutely. K1 equals 90 degrees, angle in semicircle. All right, then we can say, if for K3 equals 90 degrees, angles on a straight line. Okay, then we can also say U1 is 90 degrees, angle in semicircle. All right, and then we can say, therefore, what we've shown, and I'm not doing it the way quite exactly the same way you did it, I'm saying, therefore, U1 equals K3, and we don't need a reason for that. And if U1 equals K3, therefore, Punk is a cyclic quadrilateral. All right, and now, guys, just listen carefully to the reasons here. We can either say exterior angle equals opposite interior angle, all right, or we can say converse exterior angle of cyclic quad. Okay, do not mention a cyclic quad without using the word converse. Okay, all right. Then the next question says, prove that SO is a tangent to the circle KUST, so to the given circle. Now just be careful here, guys, because it looks like a tangent, all right? But if we go and read from the top, it doesn't say anything about a tangent. So we are now trying to prove that this line here is a tangent. Who can tell me which theorem result are we going to use to prove a tangent? Anybody? Which result? Nice and loud.
To prove the cyclic chord, we're going to use the tan chord theorem.
The converse of the tan chord theorem.
Yeah?
The
converse.
Yes, yeah. So guys, look at this theorem. At the moment, is this line a tangent? Guys, at the moment, is it a tangent? What would I have to make this red angle equal to make it a tangent? 46. Ha! Look at that. 46. Ha! Tangent. Okay, let's drag this thing around. What size would it need? What size would I need the red angle to be for it to be a tangent? 76. Let's have a look. All right. Okay, guys, it's a tangent when those angles are equal. All right. Can you tell me how to do this question now?
Angle S1 is equal to angle P1.
Just let me find them. P1's over here. S1 is over here. Why is S1 equal to P1? Okay, guys, well done. Just listen carefully. We never talk about alternate angles, corresponding angles, or co-interior angles without also talking about which lines are parallel. Okay, carry on. Thank you.
Angle K2.
Why? Brilliant. Okay, now guys, it might be that you couldn't do part A. You couldn't prove the cyclic quad. However, and this is really important, you can still use the cyclic quad result. Okay, this thing is a cyclic quad, and because it's a cyclic quad, you're absolutely right. Okay, so now what?
Therefore, angle S1 is equal to angle K2
Okay, well done. All right, angle S1 equals K2. Guys, this is really nice. You don't even need to have this reason, but it's really nice the way you've written it, the way you've said it, both equal to P1, okay? And therefore what?
Angle K2 is equal to angle S1 converse.
Okay, so not quite. Right at the end there, so these angles are equal. That's not now why. Yeah, that's right. Therefore, tangent. Okay? Okay, and the reason that it's a tangent is converse tan chord. Okay, because we've proved the angles are equal, therefore it must be a tangent. If it's a tangent, the angles are equal. If the angles are equal, it must be a tangent. Well done. Very nicely explained. So that's that question there. And is there anyone that we haven't done? Okay, all right, guys. So there is one that we haven't done. All right, it's way back on page 12. This one which we left out around standard deviation. Okay, I want to just show you something about standard deviation. In fact, guys, go to the end to a blank page. All right. Just find, it might be page 27 or something. Right. Guys, just take this down. This is about standard deviation. Right. So suppose we've got these numbers. So we've got 5 numbers, U, V, X, Y, and Z, okay? And the sigma for those 5 numbers is 3, okay? Now, guys, remember what standard deviation is. It's a measure of how spread out they are, all right? So now the question is, find sigma for these 5 numbers. U plus 13, V plus 13, X plus 13, Y plus 13, and Z plus 13. Okay, anybody tell me what the standard deviation of the new set of numbers will be? All right, so on the side here in a different color pen, I'm just going to do a numerical example. You might remember earlier today we found the standard deviation of 4, 5, and 6. All right, I don't know, do you remember that? Okay, it was a while ago. I'm going to quickly go and find out what the answer to that was. 4, 5, and 6. It's right up at the top somewhere here. Goodness, we've done a lot of work today. Okay, it was 0,816. Right, guys, what do you think will happen if we add, let's say we add 6 to all of these numbers. So we've now got 10, 11, and 12. Let's work out the standard deviation of that, and let's just see what it is. Mode 3, mode 2, 1, 10, 11, 12. No. Shift, stat, 4, 3. Ha! Sigma equals 0,816. Did it change? No. Guys, what is standard deviation a measure of? What are we talking about? We're talking about how spread out the data is. If we add the same number to every data item, do you agree that the data doesn't become more spread out? It just moves. All the data just moves. So just learn that, just understand that if you add numbers, the same number to every item in a data set, the standard deviation will not change. So for the answer for this question, as I posed it, sigma is still 3. Okay, just be aware of that. And it's fairly obvious because if you add, say, 3 to every number, the mean goes up by that amount and each number goes up. So that gap, remember this, guys. Remember in your formula, this gap, that gap will not change. Because if you add 3 to every number, this gets bigger by 3, this gets bigger by 3, and the gap doesn't change. All right, guys, we're going to stop there.